This is the very first maths question. It's somebody playing a chess competition. In each game, she can win, she can draw, she can lose. Fill in the table to show the 9 possible outcomes for the first 2 games, and the 2 are already done. So we can see here, this is a two-way table. So you've game 1 is down the side. So this should be game 1. And this is game 2. So in game 1, she could win, draw, or lose. And in game 2, she could win, draw, or lose. So in a two-way table, we combine the results of, for example, both games. So she could win game 1 and game 2, W and W. She could win game 1 and she could have a draw in game 2. She could win game 1, but she could lose game 2. Down, if we move up to the next line, so she could have a draw in game 1, but she could win game 2. She could have a draw in game 1 and she could have a draw in game 2. She could have a draw in game 1 and she could lose game 2. Down here we could see that she could lose game 1 but win game 2. She could lose game 1 but have a draw in game 2, or she could lose game 1 and she could also lose game 2. They then ask you what is the number of outcomes, possible number of outcomes if she were to play 3 games. So again, looking at all the different options here. So for example, if she was to play a 3rd game, so if we look, we're just extending what's in the table here. So if there was a 3rd game, so she could win the first 2 games and win the 3rd game. She could win the first, draw in the second, draw in the 3rd game. She could win the first, lose the second, lose the 3rd game. She could draw in the first, win the second, win the 3rd game. She could draw in all 3 games. She could draw in the first, lose the second, lose the 3rd. She could lose the first, win the second, win the last one. She could lose the first, draw in the second, draw in the 3rd one, or she could lose all 3 games. So it's just a continuation here of what's in the table. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes there.